Okay, let's figure out the length of a year on Mercury using Kepler's law based on what we know about Mars. Here's the question we're tackling. The radius of Mars's orbit around the Sun is roughly 4 times the radius of Mercury's orbit. We know a Martian year is 687 Earth days. So the question is, how long is 1 year on Mercury? And we have a few options to choose from. Is it 104 Earth days? Or 88 Earth days? Maybe 225 Earth days? Or is it 172 Earth days? Alright, let's start with the first step, understanding Kepler's third law. This fundamental law of planetary motion tells us that for any planet orbiting the same star, the square of its orbital period, which we call t, is directly proportional to the cube of the semi-major axis of its orbit, which we call r. In mathematical terms, we write this as t squared is proportional to r cubed. Now, for any two different planets orbiting the same star like Mars and Mercury orbiting our Sun, this proportionality means that the ratio of t squared over r cubed is the same for both. So we can set up this equation: t1 squared over r1 cubed equals t2 squared over r2 cubed. Next, let's identify the information that's given to us in the problem. We'll use Tm and Rm for the orbital period and radius of Mars, and we'll use TME and RME for the orbital period and radius of Mercury. The problem tells us that the radius of the Martian orbit Rm is about 4 times the radius of Mercury's orbit Rme. So Rm equals 4 times Rme. We're also told that a Martian year Tm is 687 Earth days. And what we need to find is the length of 1 year on Mercury, which is Tme. Now for step 3, let's set up our equation using Kepler's third law. We'll use our equation for two different planets, setting planet 1 as Mars and planet 2 as Mercury. So we have Tm squared over Rm cubed equals Tme squared over Rme cubed. Okay, let's move on to steps 4 and 5, where we substitute our known values and solve the equation. We plug in values like Tm being 687 days and Rm being 4 times Rme. This leads to the equation you see here on the slide. First, we simplify the term in the denominator on the left, 4 times Rme cubed, which becomes 64 Rme cubed. Now looking at the simplified equation, notice we have Rme cubed on both sides in the denominator. We can cancel this term out. This leaves us with 687 squared over 64 equals Tme squared. To solve for Tme, we take the square root of both sides. This breaks down to the square root of 687 squared divided by the square root of 64. Simplifying, the square root of 687 squared is 687 and the square root of 64 is 8. So Tme is 687 divided by 8. Calculating this gives us 85.875 days. Finally, step 6 is to compare our calculated value with the options provided. We calculated that the length of 1 year on Mercury is approximately 85.88 Earth days. Looking at our options, the option that is closest to our calculated value of 85.88 Earth days is option number 2, which is 88 Earth days. So based on Kepler's third law and the given information, the length of 1 year on Mercury is approximately 88 Earth days.